know there's that much in there.
I thought you were talking about the notes. I did take all that stuff. So what thought I would show you today is something that's sort of unrelated to the project, sort of related, but kind of unrelated to the project. And that's managing all these files that we're having now. How many classes do we have in this project?
A lot. 1, 2, 3. Including our test classes? Or
Yeah, yeah.
Is the implement class?
What?
Implement list count?
Yeah, yeah.
13
Yeah, how many like boxes do you have on your screen?
14.
6?
Well, I have
14.
I have 9.
9?
Should be less now.
Should be less now.
Well, because for this shunting yard one, you don't have to include whichever link list or array you're not going to use. There's no reason to include that.
Oh.
In other words, if I'm using
you
array.
throw it all together.
Oh, okay. Then you'll have like 14 or something. Take those 3 out and make that 11.
So we've got
Ton.
fancy array test, linked list test, list test, stack test, postfix test.
Shunting error test.
That's 12.
Node.
What? Oh, node.
Yes.
That's 13.
Then we'll eventually get.
I counted wrong.
It's close, right? Does anybody here do their work on more than one computer? A couple people do. How do you move the files back and forth?
Dropbox.
Yeah.
Dropbox.
I just,
Save it in Google Docs.
well, I mean,
Dropbox.
BlueJ just saves, so
You can import
I just
too.
move my flash drive.
Flash drive.
Yeah.
Dropbox.
I just leave it
Do
on
what?
there.
SkyDrive. So you're either using some kind of cloud thing, or you're physically moving files back and forth with a flash drive. There's a technique. It's not a product. It's a thing that developers use called a version control system. Or BCS.
Like 0.1 and things like that. So like 0.01.
Yeah. So it serves a couple of purposes. One is it preserves all the changes that you've made to a file over time. So if you're working on a project and something goes horribly wrong and you want to get back to the version you were working on yesterday, the version control system can do that for you. It also manages syncing files between multiple computers. So if you're working on your laptop and then you've got your desktop at home and you want to move your project or keep the 2 projects in sync, the version control system does that for you as well. And not only does it help keep the files in sync, kind of like Dropbox does, but you also get the complete history of your project on both computers. So I wanted to introduce version control systems to you today, and also tell you there's an additional feature that they can do, and that is to help manage sharing projects among multiple developers. So if you've got 2 or 3 or 100 people working on a project, you need to keep all the files bundled together in a version control system. So you're not passing files back and forth on flash drives, things like that. When you're working in a team, or even working with yourself on a large project, you can do something like, hey, I need to add this new feature to the program, but I don't want to break the existing program. In other words, it's kind of like, one thing you can do is, let's say the teacher gives you 5 things you need to do on the project, and any one of them can be done independently of all the others. You can do what's called a branch. You can create kind of like this side development arm of your project, work on that feature until it works, and then when you've got it working, merge those changes back in with the project itself. And so let's say with the due dates coming up and you only got 3 of those 5 things done, but you were starting to work on those other 2 are not polluting your program, the one you turn in. So you don't have to like comment out a whole section of code and say, hey, teacher, ignore this stuff, this is what I was working on, but it doesn't work. You can essentially do your development on a kind of a side version of the project, and then when it's working, bring those changes into the main project.
Is that kind of like how, I think you were talking about before, where you can like a library card, like you check out this part of the program, because I met some real life developers, and they're saying that's exactly what they do for their programming that they do.
Yeah.
check out part of the code.
Yep, and so what the version control system does for developers working in a team is it makes sure that like two people don't work on the same file at the same time and then their changes conflict with one another. The newer version control systems actually do let two people work on the same file at the same time, and they manage the merges a little bit better than the older ones do. But yes, that's generally the idea, is you kind of like check out the file like from a library, work on it, and then check it back in when you're done with it. Although these newer ones let you kind of, I guess the analogy would be check out the entire library, get what you want out of it, and then check the whole library back in. And then multiple people can do the same thing at the same time. So let's go over some version control systems that you'll hear about these days. One is called CVS, not related to the pharmacy at all. SVN, Git, and Mercurial. CVS stands for the Concurrent Version System. You'll never hear anyone say concurrent version system, they'll all just say CVS. SVN stands for Subversion. Git stands for Git. And Mercurial stands for, actually, the abbreviation for Mercurial is HG.
Because of Mercury?
Yeah. That's cute, huh?
So Git's the most popular out of them for small developers, right?
Well, the CVS is an older one. This one is falling out of favor quite rapidly, but you still see it around. So if you come across, if you go to an employer and they're still using CVS, I would like run away. Tell them we need to convert. Subversion is quite popular, works pretty well. If a project's been around more than a couple of years, it's probably still using Subversion because they need to, they've probably gotten away from CVS, but they're using this one. Git and Mercurial are the two latest ones you're probably going to run into these days. And both of them are pretty popular. I think Mercurial is probably more popular maybe among professional developers, and Git's more popular among like the open source crowd. But still quite good. There's a sort of dividing line between the two. These upper ones, CVS and SVN, are server-based, and the lower ones down here are called distributed. The server-based ones need to have a central place where the master copies of the files are kept, and then you, as a developer, check out your files from the master repository and then check them back into the master repository. So there needs to be a server somewhere set up that hosts the master files. These distributed ones don't need a master location for the files. Every computer that's developing on a project is its own master repository, and then you just sync the repositories between each other. So it's a different model than like the Dropbox model where you're kind of syncing things to a server. I want to show you today this one, Git.
What happens when on those, if somebody wrote bad code and then you sync it all, they all get that bad code? Wouldn't that be a problem?
But you can roll back that back one.
That's not
And also, all of these ones, particularly Git and Mercurial, have a feature called blame, where so you can look at the differences between the two versions and figure out what changed, what broke, and then blame the person who. I mean, it actually tells you, Ken caused this line here. Put this version of the line in there. That's what I meant.
Usually can.
But there's also a complement to that. There's praise, which is
Nobody uses that.
yeah. Ken did a great job on this one there. So.
Nobody ever uses that.
So let's see. How can I want to show you Git that you can use by yourself, and then later in the semester we'll see how it works with a team working together. So a couple websites you need to know about. Probably the most important one is GitHub.com. This is a company, if you will, that hosts repositories for you. Now, I said earlier that you don't need to have a server-based repository, but it's good to have one because if you want to sync your changes between 2 or more computers, you need a central place to put the files. So, when you get a chance, go to github.com, register for an account, and then type in a new URL, go to github.com/edu, and those of you with computers can try that right now. Go to github.com/edu, and then there should be a link up there that says, I'm a student, create me a student account. And what the student account gives you is the ability to create what are called private repositories. Now the thing about GitHub is that when you create a repository, it's public by default, meaning anyone can come to github.com, do a search for your name or the project you're working on, and get access to your files. Does that seem bad? Yeah? Well, why would they do that in the first place?
Open source stuff.
Yeah, so remember I said Git is popular among the open source community, so for open source projects, you kind of want them to be public so that people can join them and help you out. But if you're a student or you're working on your own personal projects, you need a private repository, one that you can invite other people to, but otherwise people don't have access to. So when you get a private repository, you get the ability to kind of control things for yourself. Where was I going with that? If you're not a student, and let's say you're just a Joe or Jane, somebody, then you would pay $7 a month for the ability to create private repositories. That's how they make their money. If you're a large organization where you've got hundreds of people, then you would pay even more money and have the ability to create what are called organizations, so that you could have host your entire team, your entire development environment. And those cost several $100 a month. Okay, so go to github.com, edu, create an account. This gives you the ability to create up to 5 private repositories for free. So after you've done that, you're going to go to another website. You're either going to go to windows.github.com or mac.github.com. And if you're running a Linux system primarily, you're stuck with command line. And download the GitHub client for your computer. It's a real small little program. Maybe this would be a good chance for me to show you what the heck I'm talking about. Because I can see these websites in my mind, but some of you can't. Same machines.
This is newer.
wanna turn off some of the lights? Alright, so, this is the GitHub website. You're going to pick a username, enter your email address, and create a password. I've already signed up for an account. Put that in. You will go to github.com/edu, and it says, I'm a student. Yeah, I've already signed up for the student account. But you'll click on that, and then I think it has you fill out a form, tells you what school you're at. What else? Did you do it?
Name, why you want to do it. I put student assignments.
Mm-hmm.
That's about it. What
Cool.
year you're in school
Cool.
right now?
Have they already turned around and given you access?
Not yet. Not yet.
I don't know whether it's automated or whether somebody actually goes through and does these things. Okay, and then you'll go to something like mac.github.com, and it says download. You'll download that one. So let's go to Windows, and it should look pretty much the same.
Top right.
Funny, the page looks different.
And your student email, like your name dot student dot sierracollege dot edu.
It's funny how they embraced the not Metro interface.
And let's see, yeah, sounds good.
It's not gonna work.
Easiest way to use Git Windows, period. The only way?
No, there's, if you want to get like the raw Git experience, there's another website you can go to. As soon as it's finished.
Oh, I'm not interested.
Is this already on all the computers?
No. This is something I learned last week. Before now, I've used Mercurial myself.
Cutting edge.
Yeah, so, but the Git folks were at the conference, and so I talked that length with them. And they said, hey, we got a good education program going, so we'll give it a shot this semester. Oh, it's gonna take a while. Okay, so if you want the raw Git experience, you will go to git-scm.com. And then there's a Windows client, there's a Mac client, there's Linux. If you're using Linux, you can just do the package install for Git, and you'll get the latest version.
Okay, so this one doesn't have, it's not like GitHub where I put stuff on a server, it's gonna be on my
No,
own.
it can. This Git package is what's underlying this GitHub client that we're downloading.
Okay.
So this GitHub client though gives you a nice GUI interface to access your files. This one you're downloading here, it just gives you like a command line version. That sucks. If you go on and do Git stuff more, you will probably eventually need to learn the command line, because it allows you then to get in there and fix problems with the repository, do more advanced features. But the client will work for most of the stuff you do. Is this thing done yet?
Looks like there's a Linux client too. But they're not. It's like SmartGit and GitFola. Those are two Linux clients.
Are you running Linux on your computer there?
I have a dual boot, but I'm running 8 right now.
Install. I'm sorry, the Mac version is just like, download, run it. This Windows, download it, install some more stuff. Get permission, install some more stuff. Well, while that's going, let's assemble a project. Let's go to BlueJ. this one here? Dog, corgi, shih tzu, and pug. Okay, and we made sure that this was all working. Did we have tests? No, we didn't have tests for that. Okay, so let's see, where is this project? This is, oh, there it is, on my desktop. Okay. I feel sorry for you Windows people. It's just like, oh, come on.
It's these computers, not Windows.
Yeah.
What?
It's so unfair, it's those old computers.
Yeah.
Stuff
It
takes
is.
You
so.
have to have at least 12 gigahertz computers with 15 cores, you know, to run Windows.
It's definitely the Pentium D that that computer has.
The Mac was literally download one file.
Yeah, just open everything.
Well, you will never convert me from Windows 7.
Nope.
You say the same thing about Windows XP?
We kinda have to, eventually.
Yeah, it will eventually get to that point.
Yeah, I'm on Virginia's.
2000's the last thing he ever needed. XP's the last thing he ever needed. You can try that from his cold days.
3.1 was the last thing he ever needed.
DOS.
This is Microsoft Office. I have Lotus Office.
I've got VI, anything else.
It's like a weird box.
So are you guys downloading the Windows client?
Already installed.
You're already done, right?
Yeah.
I
already installed.
don't have Windows on here.
What's that?
It already.
So I don't
set
have
the
Windows
student-
on here.
You have Linux on there or what?
It's Jelly Bean.
Oh, Android. Is there an Android? Well, do you do development on there?
You can, but it's not BlueJ, that's for sure. But they have a specific program though for Android that you can use to develop for it.
Do you do it mostly just for note taking?
Yeah, just note taking. Now recording.
It's a full Metro interface. Like, it's just weird.
This client is?
Yeah.
Oh, that's not good.
You're gonna be brought into the fold. Does it swipe and everything?
I don't have a touch screen,
But
it looks like it could, yeah.
Can't take your mouse and it's gonna swipe things back and forth?
No, it looks like it's just made to look like it. I don't have any repositories, so I don't know what it's gonna look like.
Oh, great. It's been stuck right there for the last 2 minutes.
Because these computers,
Oh, it moved. I think.
Yes.
Does anybody else do that? Their mouse?
There you go.
All right.
Sign in. It's weird how they made that box without any border at all, like, it's just really weird.
This thing here?
Yeah,
Windows 8.
that's 7 right there.
No, I mean, but it's made to, it's built with the Metro interface. How would I?
All right.
So you made a repository inside of your Dropbox?
Yeah, I was right before class. I was like, oh, I gotta just try this out. I was using Dropbox to sync between computers.
Yeah.
So we are going to add, I'm going to add this dog project to my repository, so I'm just gonna drag dogs into here, and that doesn't work.
That didn't work.
Hit skip. Hit skip.
Oh, skip.
Yeah, it's still there.
Now
Now
you-
you.
Ah, there we go.
What? What are we doing? There's skip one. That's there. Should be your first.
Okay, can you guys see this well enough? It's
Yes.
kind of small. I don't know if I can make this any bigger. No.
Yeah, that's it.
So it's asking me for the name of the repository, which is the name of the project, a description, if you want, where it's located. Now, okay, so some terms here. A repository is where your version-controlled files are stored. So there's the opposite of repository is the working files or working set. So the working files are what you would normally work on. The files you would edit, the files you would change, the files you run. The repository is where the files are stored, where they're under the version control. Did that make any sense? So the idea is, let's say you need to fix a bug on your project or add a new feature. You will add those features to your working files, and then once you're satisfied that things are going pretty well, you will do what's called a commit out of the working files and into the repository. The Git system will store in the repository all the versions of the files that you have committed to the repository. And it actually doesn't store the whole file, it just stores the differences between the current version and the previous version. So it stores the original version of the file, and then all the differences since then. And if the difference is only one line, then all it's got to do is store basically just that one line with some additional information about where in the file that line is. If you change the entire file, then of course it has to store a complete new version of the file. But the idea is that the repository contains just the differences between the previous version and the current version. So you work on the project a bit more, and then you reach a new stopping point. So you do another commit into the repository. Do that again, over and over again, and you start building up this history of your project. A good idea is every time you kind of like fix a problem or you get the project into a running state where you kind of want to take a snapshot of what it looks like right now, do a commit. And then it preserves that version. And then when you reach a point where you now want to sync the files between more than one computer, you will do a push to the GitHub repository. They have a copy of your repository, and you're now going to push everything that's changed since the last time you did a push out to the website. Now, let's say you're working on your project and you're adding some new feature and you just horribly broke something. What could you do?
Go back.
Yeah, so you go into this repository and say, show me a history of all the files, and you could pick the version that you want and say, I want to go back to that version. And then it will restore your working files back to that version. You can go and fix the problem and then do another commit. Now, the next thing would be, let's say you were working on your laptop and now you want to switch over to your desktop computer. Your desktop computer needs to have its own set of the working files. So this maybe is on your laptop, and this is on your desktop. So you need to do a, what's the opposite of push? Pull. From GitHub into a repository on your desktop computer, and then from there do an update to pull them out of the repository on your local computer into the working files. Yes?
So the GitHub is just basically, it acts as like a repository for, so you can get it from working files on your desktop?
Yeah, it's acting as kind of like a middleman to manage moving the files between two computers.
Okay.
Now, you don't have to use GitHub. You can actually, if you don't have internet access, you can just copy your repository onto a flash drive, physically take it over to the other computer, and then just say, pull stuff in from it.
Right.
And it works fine.
Okay.
But GitHub is a nice central place to put stuff. Okay, so let's try this out here. So I'm going to, here's the path to my project. I'm going to simultaneously, in addition to creating the repository on my computer, also do a push out to GitHub. And that's going to make the repository visible in both places. And I'm also going to say, make this private. Are we good?
Did you do anything for git ignore? Leave that to them.
That's where I'm going next here. Okay, so, did you see what I did? So I got this screen here, where it's showing me all the repositories that I have. And I want to see the files that are in there, because there's some files that I don't want to put on the repository. So I'm going to click, I guess it's this, little blue arrow. And these are actually all the files that are inside that folder. So look through this list here, and tell me if there are any files here that you think I don't really need to sync across computers. Okay, actually I do need these, because if I make any customizations to my repository, it stores that in those files. So I do want to sync those across computers.
README?
Well, doesn't all of it get used by BlueJ? So
Yeah.
if you're doing editing, like it automatically creates your change log and things like that, or
Yeah.
All the .class files you don't need,
Right, I don't need the .class file.
Mostly,
and you don't need README.
The README is this file right here.
yeah.
Yeah, we don't need.
This is where normally you'd like put your name.
Yeah.
Okay, but we definitely do not need these .class files. Why don't we need those?
Those are the compiled versions, and if you have the regular version, just recompile it.
Yeah, so you don't normally put into version control the compiled versions of the files, because you can always just rebuild those, it just takes a second. I'm going to uncheck those. I do need this package.bluej. This is the file that BlueJ uses to keep track of all this stuff. So we're just going to do the .class files.
What's the C text?
I'm not sure what those do. BlueJ uses them.
Conceptual text, concept text, class text.
Okay, now I need to do a commit. And I'm looking for the button that says commit.
It's right there, but you have to comment.
What?
right next to uncommitted changes on the bottom of that.
Put a message.
Oh, okay. See, the Mac client is different.
It's better.
So, commit version, commit message. Now, this is a message that you're going to see when you ask to see the history of the project. I would put in there a brief description of what you changed since the last version. Now, this is the first initial commit, so I'm just going to say initial version. Now, it still says, hey, you didn't commit these.
Add those.
So I want to say always ignore .class files. Where the heck is that? Tool, settings, ignore files. Now normally it would do this for me.
Could be in there.
Again, it's like, just a moment ago I used the Mac version and I know where everything is now.
Studio header, there's no Java.
No, then what? Math crap.
Mac crap, is that what it says?
Now it says 0 files a week. I guess that's okay. Okay, so now I got this. Now I can click on publish, and it's going to go out. Actually, let's not do that yet. We'll skip that. Okay, let's go and make some changes here. Here's my pug. Remember this one? And let's say we need to change what it says while it's sleeping. Okay, and then we can test it out. Pug E equals new pug. E dot sleep. Good. I think it's working. So if you come over back to the GitHub client, it says, oh, I noticed that pug.java has changed. So I'll click on changed sleep message for pug, and then commit. So you can see this history is building up of what I've done to the project. Questions so far?
Why is there not a date that says some crazy X?
Well, this is the date here.
Oh, that is.
This is the version number. Now, version numbers in Git are just this kind of unique identifier code. Under SVN and CVS, they just go up by 1. 1, 2, 3, 4, 5, 6. The idea here is because you can create what are called these branches, it gets unwieldy to have version numbers that are just always increasing when you've got potentially hundreds of like parallel tracks of development. So there's no real idea of like what's version 1 if there's 50 people all working on the project. So they just assign a unique identifier. What's more important is probably the timestamp on it. So rather than saying I want to go back to version 5, you just say I want to go back to the version from yesterday. Okay, and then let's go and let's do a big change here. So let's add a new thing that dogs can do.
Scratch.
Int.
Maybe
Scratch.
Age.
Get
Age.
age.
Dogs return their age.
Ruff, ruff, ruff. How many times they
He
bark?
barks.
Yeah, what are the how many times they bark?
And now I've got to add a whole bunch of stuff here. Public, int, get age. This Shih Tzu is always 5.
No, they just bark. 1, 2, 3, 4, 5.
That happened to me, I'm always 29.
The Corgi, however,
Age.
29.
not Jordy.
No way is it 2020.
So every time you ask his name, it changes?
No, the first time I create a Corgi, it will be assigned a random age. And then the pug, I like that idea where you go public, get age. It always just returns a random age. Oh, no, better, even better. get H,